Okay, can someone confirm if my screen is visible? Okay then, so let's get it started. So this is the map interface and this is a diagrammatical representation. So we have the map interface, and this map interface has already been discussed in the previous session, right? Today we will understand about the HashMap and the internal working of the HashMap. So let us do a small recap about map interface. So map interface, we have drafted about 9 points on top of map interface, right? Map is an interface and it is available in java.util package. So when you want to store the data in the form of key value pair, right, you need to use maps. And obviously it was informed in the year JDK 1.2 version. And keys must be unique. Please remember this point. And the values can be duplicated. Values can be duplicated, but you cannot duplicate the keys. So this is one of the major takeaways. And one more thing is by default the map does not follow the insertion order and it does not follow the sorting order. And heterogeneous elements are allowed at both keys and values. So these are a kind of takeaways. And the last point, you have to remember this: keys are always able to allow only one null value, right? And these are some of the significant methods that we have discussed on top of maps, right? And today we will understand something about the HashMap, right? And if you see the position of the HashMap, HashMap is directly it is implementing the map interface. So the highlighted boxes, the highlighted rectangular boxes are interfaces such as map, sorted map, and attribute. And the non-highlighted rectangular boxes are the classes. So I can say that HashMap is a class that is extending the, HashMap is a class which implements the map interface. So first point is very clear. Okay, if I want to make any point about HashMap, by looking at the diagram, I can make one point. What is it? HashMap implements map interface. Okay, and again when it was introduced, okay, it was also introduced along with the map, which is in the JDK 1.2 version. It was introduced in the JDK 1.2 version, right? The third point is so you have to remember this point. This is very, very important point. Internally, HashMap internally uses a data structure called as table data structure. It internally uses data structure called what? As table. We will understand what is as table. Okay. For the time being, just remember this point. Internally, a data structure is used to store the elements, to store the key values, and the data structure is called as the as table. Okay. And fourth point. And since it is implementing the map interface, if you see the diagram, it is very clear that this HashMap is implementing map interface. So all the qualities of map interface will also be applicable for HashMap class also. So all the qualities of map interface can be inherited to the HashMap also. Having said this, what does it really mean? You can copy all this. You can copy the from 4th point to 9th point, and same points are applicable for this HashMap also. Right? Same thing goes for HashMap also. So no changes are required. Instead of map, I will just going to change it as what? HashMap. Wherever the map is there, I will replace that with HashMap because same points are applicable for HashMap also. Right? So no need to keep much explanation about this. And the 10th point I can say it is like capacity. So when I am talking about the capacity, so for example, the HashMap, if I am creating a constructor for the HashMap, so HashMap, okay, string I am taking two generic types of string type. So one generic type is representing the key, the second generic type is representing the value. I want to store some information about the countries. I'm creating an object for the HashMap itself, right? So the moment I do this, so what is what is going to happen behind the scenes? Let us use this space. Because of this piece of code, okay, because of this piece of code, let me increase upon. Okay, because of this piece of code, an HashMap internally a data structure will be created. An array will be created of size 16. Okay. So this piece of code is creating this many indexes behind the scenes. Totally 16. Yes, an array will be created of size 16 and the index number starts from 0 and etc. So this piece of code is creating this many spaces behind the scenes. Please remember. So having said this, when I want to represent it in the theory, I can say that the initial capacity is 16. Initial capacity is 16. It means the moment you create a constructor, 16 spaces, an array will be created of size 16. No need to keep much explanation for this, okay? This 11th point. It's load factor. It's load factor. So when I talk about the load factor, it is going to resize the array after reaching a saturation point. So the load factor is 75%. So 75% says, when I say that load factor is 75%, as soon as the 75% of the storage is filled. Okay. So what is the 75% of 16? So we have 16 spaces. So 12 is the 75% of 16, isn't it? Yes or no? Right? As soon as 12 spaces are filled. Right? As soon as 12 spaces are filled, the load factor will come into the picture and it is going to resize the existing array. This existing array will be resized in such a way that the size will be doubled. The size will be what? The size will be double. Instead of 16, it is going to have 32 spaces. Okay, 32 spaces. Just for the understanding, just for the visualization, I'm using the paint screen. So these are the things that is going to happen behind this. That is called load factor. What is load factor? The moment you fill 75% of the capacity, the size of the array will be doubled against its original size. What is the original size? 16. 16 becomes 32. That's it. Right? So this point is giving the justification. Its load factor is 75%. And the 12th point is, it is not synchronized map. So it is not synchronized map means multiple threads can get access to this hash map at the same time. Okay, the 13th point. No methods in the hash map is synchronized in nature. Synchronized in nature. So each and every point is related to each other. 14th point, because of this nature, it follows parallel execution. Okay, 15th point, it is not thread state. Okay, 16th point, its performance is going to be high. Okay, 17th point, there will be no data consistency. So these are the points that we will discuss in the multi-threading concepts. There will be no data consistency, or I can say the data consistency will be open. So these are the 17 points that we have when you talk about the HashMap, right? So next thing is methods inside the HashMap. So there are no specific methods inside the HashMap. All the methods that we have used for the maps will be applied for the HashMap also. So all the 11 methods that we had discussed in the maps concept will be applied to the HashMap as well. So we are not going to discuss any new methods because we are going to, it is going to follow or utilize the existing methods that is applicable for the map. So it has been already been discussed. Okay, there are 11 methods. 11 methods is applied for the HashMap as well. Right? So we need to discuss about constructors. Constructors inside the HashMap. So there are about 4 constructors inside the HashMap that you want to aware of. Okay, the first constructor is the default constructor. So public HashMap. Okay, so this default constructor which I have just explained. Okay, this is called as the default constructor. When you create a constructor, when you create an object, okay, so this is called as a default constructor. And by using this, okay, what are the things that are going to happen behind the scenes? This will be created. An array of size 16 will be created. An array of size 16 will be created by the default constructor. And there is one more constructor that you have where you are allowed to define the size. The second constructor is public HashMap. Okay. You are allowed to define the initial capacity. For example, if you don't like your HashMap to get 16 spaces of memory, by default it is going to give you 16 spaces. 16, an array of size 16 by default. An array of size 16. It is going to give you an array of size 16. But you don't want 16. You are thinking that 16 is a very big size. You want to reduce the size. If that is the case, you have an option to deal with the size also. Right? You can define your own size. Right? So I can input here, like if I input the number 8, an array of size 8 will be created. So instead of 16, so this is going to do what? This is going to do something behind the scenes. You have a control, you will get a control to define your own size. What is the size that I am defining here? 8 is the size that I am defining here. Okay. So you get an array of size 8. You get an array of what? You get an array of size. So this will be given. You have such control. So this is the functionality of the constructor where you have an option to initialize the size, initialize the capacity. If you don't like it, if you want to define the capacity as 2, you can do that also. So only an array of size 2 will be created. Right? Hope you are able to get this. Hope you are getting this. Okay. And the third constructor that we have is public HashMap. Right? And this is a constructor where it will allow you to define the capacity as well as to define the load factor. Okay, the actual load factor is 75%. If you don't like 75%, you can give the load factor as 50%. Having said this, I as a programmer, I have a control of defining my own size. I want to define the size as 10. I want to define the load factor as 0.50f. Okay, the moment I do this, behind the scenes, let us understand how the things are going to work behind the scenes. Right? So the first number talks about the capacity. This is talking about what? Capacity. Okay, the second number, 0.50, it is going to talk about what? The load factor. Right? So the capacity is going to create the array of size 10 because 10 is the capacity. So behind the scenes, an array will be created of what size? Of size 10. So when I say size 10, the indexing will start from 0 to 9. So obviously, an array of size 10 will be created. Okay. I have also mentioned that the load factor is 0.5f. It means 50% of the, whenever the array is filled by 50%, whenever the 50% of the array is occupied or spaces are filled, the size will be double. The size will be what? The size will be double. doubled by its actual size, actual capacity. Actual capacity is 10, the size will be doubled to 20. Hope you're able to get this. Right, no explanation is required. Right, the last constructor that we have is public HashMap, and this constructor will allow you to pass a map itself. Okay, it's very simple, guys. So let us understand this in the programmatical way. I have defined an HashMap with the default constructor, right? So I am also doing what? So I want to print the reference variable. When I print this reference variable, since we haven't added any value, the output is going to be empty. The output is going to be empty. Now what I want to do, I want to create another HashMap. I want to create an object for another HashMap. This time I want to make it as something like names. Okay, reference variable is names. I'm adding some key value pairs. So let us add the name as Ratna, right? And assuming that we are going to add key value pairs in such a way that key is going to be the name and the value is going to be the location. Let us say that Ratna is from Chennai. Okay, let me add 3 names. So let us add the second name, Shashwant. Shashwant is also from Chennai. Let us add the third name, Vijay. Let us say that Vijay is from Bombay or Mumbai. So 3 names are added. So I can pass this reference variable. I can pass this reference variable to what? To a different HashMap. I can pass what? I can pass this reference variable. This reference variable to a different HashMap. Let us assume that I have added some names, right? And I have created the another reference variable as duplicate, right? I can pass this reference variable in this constructor, and when I print names, when I print duplicate now, okay, I will get all the key value pair information related to the constructor. So I have just passed this reference variable. This reference variable is meant to what? Means to add some data in the form of key value pair like Ratna, Chennai, Shashwant and Vijay, so on. Right? I am creating another constructor. I am using the reference variable as duplicate. I am just passing these names over here so that all this information is copied to this reference variable. Okay. If I do print this names reference variable, and if I do print the duplicate, which is also a reference variable, I get the same output. Don't you think so? Order is order is changing. Forget about the order. I am getting this order is changing because of the internal hashing technique. But I am getting the same output. No values is missed here. Vijay is there, Ratna is there, Shashwant is there. Here Ratna comes first, Vijay comes first, Shashwant is coming. Forget about the order. We are going to think about the internal working. So you have an option to pass a reference variable to the constructor of another HashMap so that all the values are all the values get copied. So this is the functionality of the last constructor. These are the 4 major constructors. Okay. Now let us understand the internal working of HashMap. This is a very, very popular interview question. Very, very important interview question. Internal working of. Even if you are a beginner or even if you are an experienced person, you cannot escape this question in the interview. When you say you are good at, usually what happens in the interview review? No? They ask you to rate yourself out of 10. First question would be like when you say that you are, Java, they don't directly jump into the questions. Instead, what they do, they ask you to rate yourself in Java out of 10. Usually, if you rate yourself as around 7.5, because no one like to rate themselves as a below average guy. Everyone, even whether they know or they don't know, they rate themselves 9. Or some people they rate themselves 9.5, and brilliant experts they rate themselves 10. Even though they they are not qualified enough to rate themselves 1, also they're going to give them a good rating because of the confidence that they have. Or because of to get a good impression from the interviewer, they rate themselves very high, right? So if you give your rating as 7.5 to 9, you will get this interview question, internal working of HashMap. Okay, so please stay focused for the next 20 minutes. This is very, very important. Okay, so let us start. Now I will remove all this. Okay, I will remove all this. I will remove all this. So what are the things that is happening behind the scenes? Let us understand. I do not want to take names here. Instead, I want to take countries here. Let us deal with countries. Okay, let us deal with some countries. So I want to add few countries. I want to do what? I want to add few countries. So the first country. Okay. So I would like to add a country like Russia. I want to add the country and its capital. What is the capital of Russia? Moscow. Don't worry about this data. Right? Let us worry about how it is getting stored internally, how the internal things are working. Okay. Second country I want to add, like, Canada. What is the capital of Canada? Right? You can correct my spelling if I make any mistakes. Okay, I want to add, India. What is the capital of India? New Delhi. Right? And I want to add, let us say country like, Egypt. Egypt. Okay, what is the capital of Egypt? Cairo, isn't it? Okay, 4 countries are added, guys. Now you see, when I add 4 countries, okay, look at the order here. So we have Russia, followed by Canada, followed by India, followed by Egypt. Okay, this part is called as key. The the left part is called as key. We have 2 data here, 2 sets of data here. Okay, one is in the left hand, towards the right we have 1 data. Towards the left we call it as key. Towards the right we call it as value. That's why we call it as what? Key value pair. A pair that is representing a key and representing a value as well. We call it as what? Key value pair. Right? So you have Russia, Canada, India, and Egypt. Okay, this is the order. So run this example. The order is getting changed. Forget about why it is getting changed. And if you see the output is not in the form of sorted order also. I cannot say the output is sorted order. And also I cannot say the output is preserving the insertion order. Okay, I can see, you can visualize these things, right? No insertion order is followed. Insertion order is not maintained. Right? Second one is sorting order is also not maintained. This is the 2 major observations that we can do. Okay. Now you see, guys, if I want to add a duplicate, okay, I can have duplicate keys, but I cannot have duplicate. I'm sorry, I'm just saying the opposite. I cannot add duplicate keys, but I can add duplicate values. Having said this, if I try to add India again, once again, if I try to add India once again, okay, and if I try to, add a duplicate key, and let us say that New Delhi. For our observation, I'm saying, okay. So let us see the output and we can make some judgments. The output says India, New Delhi. There is a key value pair, but the value is replaced. Previously, New Delhi was with a space. Now it is accepting the New Delhi. When I say New Delhi, the new key value pair that is recently added. So this is going to get replaced. So in this case, I can say that duplicate key is not allowed. This is the third observation. We will understand all these things internally. Duplicate keys are also not allowed. Third observation. Right. Fourth observation. I want to add the country. Let's say that I want to say USSR. USSR is a former, previous name of the country Russia. Soviet Union, right? And it has been divided into many parts. So just for our understanding, I'm saying USSR, Moscow. The capital of USSR is also Moscow, right? If I run this, So now the value is duplicated, but duplicate values are allowed. See, you are getting two Moscows. Why you are getting two Moscow? Because you are allowed to add the duplicate value, but not the key. Right? So fourth observation. Duplicate value is allowed. Okay, and the fifth observation, let us make the fifth observation. Countries dot put. I want to add a null key. I want to add a null key and a null value. Let us understand whether this is allowing the null key or value. It is null key also allowed, null value is also allowed. Okay, null key and value is also allowed. Right, so these are our observations so far, isn't it? So what is happening behind this, that we will understand now. Okay, this is our code. I will place this in the notes. Okay, so let us understand the internal working of the HashMap. First point, guys, please observe. HashMap internally uses an hashing technique to store key value pairs. Key value pairs. So what is this hashing technique? What does it mean when I say hashing technique? What does it really mean? Any idea for this? So hashing technique is very simple, guys. Okay, let me remove all these. Let us, for the time being, let us understand that we are dealing only with the 4 countries. So these things are included in the notes. No need to worry about this. Okay, this is a key value pair. Okay, let me copy this code. Let me paste it here. Let me paste it in the paint slip. We are going to deal with this four lines. Okay, the first line has already generated 16. It has already created an array of size 16. So we are done with the first line. The remaining 4 lines, we need to talk about the remaining 4 lines. Okay, what are the things that are going to happen with these 4 lines? So look at the first line. We are using a put method, and we are adding two kinds of data. One is the key, second one is the value. The key is Russia, right? So it will consider the key first. Firstly, the key will be considered by the JVM, and this key will be converted to an hash code. Right? After having it converted to an hash code, it will perform a modular operation. After performing a modular operation, it will get an index number or a bucket number. It will get an index. Okay, let me repeat. So these are the things. Okay, JVM is going to take the key. Key is Russia. Okay, focus here. Key is Russia, and this key will be converted to an hash code. Right? The hash code, it will perform a modular operation on this hash code to generate an index number. Okay, this complete technique is called as what? The hashing. This is called as what? Hashing. Okay, so now let us go back to the program. Okay, this is our code. Let us try to find the hashing technique by using the same program. Okay, so I want to do what? I want to create a reference variable as hash. Okay, so this is the key, right? Russia is the key, and this key will be converted to what? Converted to an hash code. Focus here, guys. This key will be converted to an hash code. Let us try to print the hash code. Okay, from the line number 21st, these are the things that are going to happen behind the scenes. I am just I'm writing all these things to make you understand. Okay, don't think that you need to write all these things. You're trying to understand internal things. Okay, internally, go back to the code. The key will be converted to hash code. Okay. The key is Russia is the key is getting converted to hash code. Let us try to see what is the hash code of Russia. So this is the hash code of Russia. Focus here. This is the hash code of Russia. This is the converted hash code of what? Russia. Okay. After this, we'll go back to the point. There will be a modular operation. Okay. The formula for modular operation is as follows. Integer index number equal to, I am using the reference variable name as index number to store the bucket number, the index number that is getting generated by using the modular operation. Okay. So you need to use this hash, this this reference variable which is hash, followed by the AND operator. Okay. 16 is representing the number of size of the array, size of the original array, size of the array, -1. Again, I am trying to print the index number. Okay, so we are getting the index number as what? 11. Focus here. 11. So these 4 lines of code, they are being used behind the scenes to generate the index number. This process is called as what? Hashing technique. Okay, so what I just said, the key, this is the key. The key is getting converted to hash code, followed by a kind of modular operation is performed to generate index number. What is the index number that we have got? Index number, we got it as what? 11. 11 is index number. Okay, it will try to find the index number 11. So this is where the 11 is, right? So it is going to store 4 set of data inside this space. Inside this space, it is going to store 4 set of data. What is that 4 set of data? Okay, the first set of data is what? It is going to store a node. Okay, node. Each and every index, the array space is called as node, which is going to store the key value pair, key comma value. Okay, it is going to store the hash number, hash code number, hash code. Secondly, it is going to store the key value of store the key data. It is going to store the value data, and it is going to have a node reference. This is the node reference, key value, which is going to point to null. Okay, now let us go back to the code. So what is the hash number that we got? So this is the hash number, right? So this reference variable is going to have this hash number, something like it's a very big number, right? So you cannot keep this as an index number because our size of an array is limited. It is very limited. It is just 16, right? It is a very big number. So we are performing the modular operation. Modular operation is being performed to get this number between 0 to 15. That's why the modular operation is getting performed. Right? Such a big number, you are ensuring that a small number is getting generated by the help of what? Modular operation. Okay, so this is the formula for modular operation. Using the hash code followed by AND operator, 16 minus 1. Where 16 is representing what? Size of, we can also do integer size equal to 16. Okay, so instead of using the 16 here, I can use size, right? Focus here. Now the key is what? Russia, right? What is the value? What is the value that we have? Moscow, right? So this piece of information will be stored in the bucket number that has been generated, which is 11, right? 11 is the bucket number. So this piece of information will be stored here, right? So you don't call this as an index anymore. You call this as what? You can call this as a bucket. Why you can call this as a bucket here? Because it is storing how many set of data? It is storing 4 set of data. It is storing how many set of data? 4 set of data. That is why you call it as what? A bucket or node, you can call, or node. It is storing 4 set of information. It is not really visible, isn't it? Right? So what I will do, I will minimize, or I can do something. Let me expand this. Okay. Okay, any whatever it is. So we remember what is this, right? I will keep it here, right? So this is the hashing operation. So we have done with the first line. We have done with what? We have done with the first line, right? So let us consider the second line, second line of code, which is what? Canada, and the value is Ottawa. Okay, so it will consider only the key, guys. What is the key? Key is Canada. Right? Instead of Russia, you need to do what? You need to use Canada for the hashing technique, isn't it? So Russia, remove Russia here. Okay, and please place Canada here. This Canada needs to get converted to what? Hash code, right? Let us do the same thing in the program. Okay, instead of Russia, remove Russia and place Canada, right? And let us run this. Okay, the hash code value of Canada is something like this, a positive number, right? And the modular operation is generating an index number 14, right? 14, isn't it? So we need to deal with what? We need to deal with key. Okay, the node will be considered. So this is going to store key value, right? Followed by int hash number, followed by the key, followed by the v value, followed by the node key value. Initially it is going to point to null. You'll understand this. Okay, initially it is going to point what? Going to point to null. So what are the values that we have got here? So we have the hashes. This is the hash number. Okay, this is the hash number. A very big number. So we need to concise this number. We need to limit this number to a smaller number. We need to convert this number to a smaller number by using the modular operation. So this is what the modular operation is. This is what the modular operation is. Right? And it is generating an index number as 14. Right? What is index number that we have? 14 is index number. So this is the 14 number. And what is the key that we have? Canada. What is the value that we have for Canada? Ottawa. Okay, in the index number 14 or in the bucket number 14, these values will be stored. Right? It's not visible. You just repeat the video, we'll understand. Okay, so what are the, so this line is also done. So this many things are happening behind the scenes. Okay, we think that we just give the numbers, we just give the data, and it is going to consider our data and it will be printed on the console. No. These are the things that are going to happen behind the scenes, and this is a popular interview question. So what is the third country? Third country is India, right? And for the country India, the same thing has to follow, right? The hashing technique, the hashing concept. So this, now remove Canada, and here what we have? Country India. Okay, so India will convert into an hash code. The string India will get converted to hash code and modular operation to get an index number. Right? So instead of Canada, let us replace this Canada with the country India. Now let us generate what is the hash code. Let us try to, okay, this is the hash code and this is the index number is 7. Right? Index number is what? Generated as 7. So 7th bucket will be reserved for the country India by using what? We have a key. When we have a node, this node is going to have key value, or I can say the key right, hash number, and we have ks key, we have vs value, okay, and we have node key value is going to point to null. Okay, so what are the values that we have? The hash number is, this is the hash number. Okay. Hash number, a very big number, right? And we have the key as India, and we have the value as what? New Delhi, isn't it? Okay, so this piece of information will be stored in the bucket number 7. Okay, focus here. One more. Okay, India is also done. And last country is what? We have Egypt. We have Egypt. Okay, so Egypt is the key. Let us replace this with Egypt, right? And so we have an hash number. So all these values follows. What is the key? Egypt. What is the value for this particular key? Cairo. Okay, well, what is the hash number? This is the hash number for the country Egypt, right? A very big number, and a modular operation will happen behind the scenes. That is going to generate an index number, which is of what? Index number is 11, isn't it? This is the key. The index number is 11, right? And when you see now, okay, now this point needs to be identified. Now, if you see, the index number is already occupied by the country Russia. Country Russia is already occupying the particular bucket. And again, this Egypt is also getting the same bucket number, which is 11. Once again, it is already reserved by the country Russia, but the Egypt is also getting the same bucket number. So, whenever two keys, let me repeat, whenever two keys are getting the same bucket number, we call it as what? The hash collision. What is an hash collision? That is another real question. What is an hash collision? Right? When the different keys in the hash map are hashed to same bucket number. We call it as, or it is called as hash collision. It is not necessary that we are going to get the unique bucket numbers. That is not the case, because it is internally using a mechanism. That mechanism can be what? Can be a kind of violated, or that mechanism is going to have the two different keys to have the same bucket number. Right? That concept is called as what? Hash collision. Okay, now what will happen? Okay, so this is going to do what? Okay, this will not get stored in a different bucket number. It is going to use the same bucket number, but not inside here. A kind of linked list will be created next to this. It will be added next to this, and there will be a connection between these two. There will be a connection between these two. So a kind of linked list connection. Okay? So a kind of linked list connection will exist between these two. Okay, the actual bucket is occupied by the country Russia, because the key Egypt is also getting the same bucket number. A linked list will be created. This concept is called as what? The hash collision. This concept is called as what? The hash collision. Right? So this is how, okay, our four values got stored. This is how it got stored behind the scenes. Right? Now let us understand few more things. Now I want to add a null value. I want to add something like countries dot put. Okay, I want to add a null value, null key and the null value, null key and the null value. Okay, so for every null value, for every null key, by default the index number is going to be always 0. This is also the follow-up interview question. Okay, please be informed that. Let me write it here. please be informed that for every null key, the index or the bucket number will always be generated as 0. Okay, so what do we have actually? So this is we are using a put method to add a null key and to add a null value. So we have used a put method. Okay, so we have a kind of now the bucket is going to store so many data. One is the node information with key value. Yeah, the second one is the key information. I mean, int hash information. The hash is always going to be 0, right? And the key information, the key is null. The value information, value is also null, right? And the node key value, which is going to hold the address, which is also null. It is also null. The bucket number will always be 0. For the null key, the bucket number is always going to be 0. So this data will be stored in the 0th index or the 0th bucket. Right? Now let's say I want to add the country India once again. Okay, now I am trying to deal with the duplicates. I want to add the country India once again. Countries.put India I am adding once again, but I am changing the value as New Delhi here. I am changing the value as what? New Delhi. So what will happen behind the scenes? So for the country India, the hash code, it is going to use the hashing mechanism. Hash code will be generated and followed by the index number. Don't you think that it is going to have the same hash code and the same index number as it was generated previously? Right? So the hash code is same and the index number is also same. Right? If you go back to the code and if you see for the country India, the same hash code is already there. It is already existing. Hash code is already existing. Right? And index number is already 7. Okay, if it is going to generate the same hash code, okay, by looking at the hash code, it can consider that the key is duplicated. Key will remain the same. And the value will be replaced with the latest value, which is also a New Delhi, but which has no spaces. Right? So let us understand this in a different way. So this is we have already the country India that has occupied the index number 7. We have already country India that has occupied index number 7. Okay, I want to add India once again. I'm adding India once again. So for the key, the hash code will be generated. Okay, the hash code is same as the previous hash code. This will not change. Okay, and the index number is also generated. Okay, hash code is what? 70793495. Right? And the index number is 7. Okay, first it will go to index number 7. It will try to find if the hash code is same. Yes, the hash code is same. Okay, so when it has the same hash code, what it is going to do? It is going to replace the value. In our case, the hash code is same. See, the previous hash code is 7078345, right? Because key is same, the hash code obviously is going to be same. Okay, but the value is new space Delhi. This will be removed. Okay, this will be removed, and the value, or the latest value that we have just added. Okay, that will be added here. New Delhi without spaces. Okay, and this will be stored in the bucket. Right, this will be replaced. Now then no linked list will be created. Okay, the existing value will be replaced with the new value. Simple as that. No linked list will be created. Linked list will be created only when two different keys are getting the same hash code, but here the key is same, so the value will be replaced. That's why duplicates are eliminated. This is the reason why duplicate is eliminated. Right? So let us understand one more thing. So duplicate is also emitted. So now see, if I retrieve this, okay, if I try to print the reference variable, what happens? A cursor will be created. A cursor will be created. It will fetch value starting from the 0th index or the 0th bucket. So what is the 0th value in the 0th bucket? Null is the value, followed by the country India, followed by the country Russia, followed by the linked list. You know, it has already a linked list is created. So Egypt will be printed and the Canada will be created. That is the reason why, because of this retrieval operation, it is not following, it is not preserving the insertion order. Okay, remove this. Because of this insertion operation, because of this retrieval operation, insertion order is not preserved. Insertion order is not preserved. Sorting order is not because of this reason, right? So we are good with the functionality of put method. Okay, I want to understand how the get method will work. Okay, let me remove this. I want to use a get method. For example, system.out.println, right? I want to use a get method. Countries dot get. I want to pass an object. So for the country India, I want to get the value. Now understand this, guys. Focus here. Okay, I am using the get method here. This is a different method, not the put method. Get method. Okay, so get method. So the moment I use get method, again the get method is going to do what? It is going to generate the hash. I mean, it is going to use the hashing technique. This key will be converted to an hash number, and a bucket number will also be generated like this wise. Okay. So this is the get method. So I want to, for the country India, the hash code will be generated, followed by the index number will also be generated due to the modular operation, right? And it is printing the values New Delhi, right? How it is printing? It has got the hash code number, it has got the index number. Okay, the index number, by using the index number, the cursor will directly, this cursor will directly go to the respective index number 7, right? And it will check the hash code number 70 something, 7079345, and it will retrieve the value New Delhi, right? And this will be displayed to the console. This will be displayed to the console. Likewise, if I use the get method on top of the country Egypt, right? What happens? This Egypt will be converted to hash code followed by the bucket number, isn't it? Again, this Egypt needs to get converted to hash code followed by the bucket number. So hash code is 669111291 and it got bucket number as 11. There is a cursor. We have a cursor already. The cursor will directly jump to. Okay, let us create a cursor once again. The cursor will directly jump to the bucket number is 7. 7, no, it is what? For Egypt, it is what? 11. Okay, 11. And by using the hash code, what is the hash code? The generated hash code 7079345. Okay, it will check the hash code of Egypt. It is not 70 something, I mean 669111291. This is hash code. Okay, 201. This is hash code. After finding the hash code, it will retrieve the value Cairo. Because in the 7th index there are two set of data. One is for Russia, second is for Egypt. Okay, by looking at the hash code, it can come to a conclusion that we are looking for the specific value Cairo, because here we have different hash code and we have different hash code, but the common thing is the index number 11. Okay, how it will identify the exact value? By using the hash code. Okay, it is going to return the value Cairo to the console. right? So this is how the hash code, the functionality of this is how the hash code, the hashing technique works internally. So internally it is going to use the hashing technique, and the hash code, it is going to generate an hash code followed by the modular operation. After that, a unique index number is going to get generated, right? And one more thing, so sometimes this linker list will keep, okay. For example, if you're adding some 100 sets of data, if you're adding 100 key value pairs, there are high chances that one bucket number is going to have the multiple entries, right? So 10 values can have the same index number. In that case, it is going to generate linked list pattern like that. Okay, linked list pattern. There is a saturation value. There is a saturation value of weight. As soon as it reaches this saturation value, that linked list will be converted into red black tree to perform the lookup operation, searching operation with echo of login. I'll tell you what is this. Let us write some theory first. HashMap internally uses hashing technique to store what key value pairs. Hash function. So what is a hash function? It converts a key into an integer. Which is called as what? Hash code. So the hash code will determines the index number in the underlying array, where the key value pair needs to be stored. If you get locked out of this meeting room, please rejoin this. It's not going to take more than 10 minutes. Okay, please rejoin. So this is the first part. Okay, what is an hash function? So it is internal function. It is going to convert this hash code, the key into the hash code, followed by the modular operation. Okay, and which is going to determine the index number. So this is the theoretical part. Second one, what is a bucket? Okay. The array is divided into buckets. Why it is called as bucket? Okay, why it is called as bucket? Because the each and every node, okay, each bucket can store multiple key value pairs to handle collisions. Key value pairs to handle collisions. So this is the functionality of what? Buckets. Okay, nodes. So we have what? Nodes. I was talking about the word nodes. So each bucket contains a linked list where it gets created during the hash collusion, and these nodes are used to store the address of the next created bucket. So what does it really mean? So when you go back to the diagram, so when two keys are getting the same index number or the same bucket number, a linked list will be created. So this is called as a linked list. And again, if the third key is getting the same bucket number, okay, so here again a linked list will be created. If we have the fourth bucket, a linked list will, I mean, if the fourth key is also getting the same bucket number, it is going to create the linked list like this. Right? So each and every node is getting linked like this. Okay. So the moment it reaches the saturation point, okay, how many nodes are there? 1, 2, 3, 4, 5, 6. The moment it reaches the saturation point, which is 8, okay, which is 8, okay, there will be no linked list. Okay, if the ninth node is also getting the same bucket number, instead of linked list, this linked list will completely get converted to what? Completely get converted to a red black tree. It will be converted, instead of linked list, it will be converted to a red black tree to achieve the, to get the searching operations very efficient. Right? Because this linked list have the searching operation of big O of n, which means at any point of time, in the worst case, you need to do n number of searches. For example, if your value is identified here, okay, if the key is identified here, the key is located here, it has to start searching from the beginning, from here to here, 3, 4, 5, 6, 7, 8. It has to complete searching all the nodes. This is the worst complexity. It has to take n number of searches. Right? So that's why it is getting converted to the red black tree. This is how the red black tree looks like, or the balanced binary tree, I can say. Right? The searching operation will be reduced to what? Big O of log n. Big O of log n. At any point of time, it will take logarithmic of n times. Depends upon the height of the binary tree. Right? At any point of time, it is going to search the value in the log of n times. If you have 8 nodes, at any point of time, your search page is limited to 3 times. You start from here, it will check whether this value is here or here. If it is here, okay, it is, and if it is going to identify here. At any point of time, it is going to have the less number of searches compared to linked list. Linked list is going to have the maximum number of searches. In the worst case, if you have the key in the last node, but if you convert this to the binary tree, it is not going to have n number of searches. It is limited to log n of searches. Right? So you don't need to worry about this. These things won't be asked for you at all. This is for your understanding. Right? So nodes. So each and every node is converted to a bucket. Here for the insertion operation, we know how it is going to follow the insertion operation. For the deletion operation, we have known performance, time complexity. When you talk about the time complexity, average case time complexity for insertion, retrieval or deletion is big O of 1. Okay, what does it really mean? Average case time complexity for insertion, retrieval or deletion is big O of 1. Average case. What does it mean is, so whatever, if you want to insert an element, it is going to take a kind of, just imagine that it is going to take a fraction of seconds. I mean, it is going to be very quick. And for the retrieval, if you want to get some data, if you want to get some value information, very quick. You want to delete something, it's very quick. Why it is very quick? Internally it is using the hashing technique. The key is getting converted to the hash code, and the hash code is getting converted to the modular operation, and you are going to get what? The index number. So these operations are very easy to do, very easily done by Java. It will not take much time. Index number will be generated directly by following all this process. This process is not a time consuming. It is generated quickly, and the cursor is directly going to move to that particular location, and the value will be inserted or deleted or retrieved. That's why it is called as average time process or insertion, retrieval, and deletion is big O. Right. So worst case time complexity can be, worst case is big O of n for the linked list during collision. During hash collision. The worst case time complexity by using linked list, for linked list. Okay. Log of n for red black tree or balanced tree. Okay, so this is the internal working of the HashMap. If you are getting this kind of question, you need to explain this one, and you need to explain this one. Okay, and you need to explain the process which I have just mentioned. So this is the, if you remember this keywords, the key converted to hash code followed by model operation, index number will be generated, right? And if you also want to remember this, what is an hash collision is also important, right? And we got to know why it is not following the insertion order and why it is not following the sorting order, right? So try to do this from your side, you will get the better understanding. So this is all about the internal working of HashMap. They ask you this question, you should be in a position to say all this. Theoretically this would be fine. Till here it is completely fine. Remember this, theoretically these points would be fine, but when you get a question like internal working of HashMap, explain one by one how this is getting inserted. Right, these are the observations that we have done. Why it is not maintaining insertion order, sorting order, why duplicates are not allowed, and why only one null key is allowed, right? Why duplicate value is allowed. So this is the explanation about internal working of HashMap. This is all about the today's topic. Right, tomorrow we will complete discussing about the linked HashMap followed by the hash table. Hash table also will explain you the internal working. That's all from my side for the day.